So now we're going to go over dust collection technologies that we often find in cement and mining plants. Now, some of these you may find at your facility, others you may not, but we're going to review all of them so we get a good overview. In many plants, we see there's a mix of legacy equipment. You might be familiar with these or other systems, but you might be surprised that they might not be the best for your application. They might be holdovers from an earlier time when the technology was less advanced, or might just reflect older ways of doing things, or perhaps just were a less than optimal choice at one point in time that over the years, the reasons why certain things were put in has kind of been lost. But we're going to give a general overview of everything, and that will kind of help us to recognize perhaps where we have deficiencies that we can improve with either new technology or simply by redoing something with the appropriate solutions. So let's start with our dust collectors. First type of dust collector that's very common to see in mining applications are cyclones. So cyclones are a type of mechanical separator, mechanical dust collector. So there's no filters inside. A similar device would be something like a classifier, but also knockout boxes. There's a bunch of these mechanical separators, mechanical dust collectors in use, but they all pretty much do the same thing. They remove dust by having the dirty air enter the dust collector, spin around or impact some plates inside, and that sudden change in direction of the air, as well as in the cyclone where it spins, the particles eventually hit the outside of the cyclone wall, and then they slow down and they fall out of the airstream. And then the air exits and goes out somewhere else. Now, most cyclones are used as pre-filters, and this is because even the most advanced cyclone or multi-clone or whatever you might have, it will not remove enough of the dust for you to exhaust it straight out to the atmosphere according to environmental regulations. So you can't just use a cyclone. However, in mining and cement, we often use them not just to lighten the load before it goes to the dust collector with the baghouse. Well, in some applications, we use them to separate material by size. So depending on how we size and use the cyclones, but we can get a certain range of particle sizes that are removed. Say, for example, we have a mix of different particles from very fine, but we have a lot of material that's, let's say, 50 to 100 microns in size. We want to use that for something. So what we might do is size the cyclone so that it only removes particles in that size range and lets the fines continue on. A very common application is a Raymond mill, where you'll usually have a very big cyclone that sucks up all the material that comes out of the Raymond mill. Perhaps it's not been milled down to the right size. And then it's removed and put right back into the Raymond mill to keep processing it. And then we bleed off some of the air from the cyclone that has the fines in it, so the material that's gotten smaller than we want, and that goes to the baghouse. It's a very common application or usage for cyclones in the mining and cement industries. So again, good for pre-filters, remove most of the dust, and oftentimes are paired either for some process reason, but often are just used to lighten the load, the dust going to the baghouse. So moving on to the next most popular kind is the baghouse. So baghouse dust collector filters inside. These are used exclusively because they're the only modern system that will allow you to take in anywhere from a small amount of dust to an immense amount of dust and then exhaust the air out to the atmosphere and comply with environmental and safety regulations. So the baghouses are just one kind of dust collector that has filters in it. That's the most common. You also have, as we'll see, cartridge collectors and pleated filter bags that go in baghouses. But baghouses are found on everything you can see in a mining or cement plant, from dryers, conveyors, crushing, refining, milling, as well as transportation. Various forms of baghouses are present in all those different spots. Let's see now, a detail here is the type of filters we use in the baghouses. So as I said, we use fabric filters in the shape of bags in the baghouses. The most common materials we make the bags out of are going to be polyester. And then for temperatures that are a little higher, I think dryers, kilns, things like that, we're usually going to see aramid bags or Nomex bags. So the polyester bags are good up to about 265 degrees Fahrenheit. As long as we're under that temperature, we're pretty much going to use polyester bags exclusively, because they're the cheapest, the most robust, and the most widely used, and least reactive. If the temperature exceeds that, then we're probably going to go to aramid next, which also is very robust. And then in certain cases, if the temperature is above 400, which is about the limit of most aramid medias, then we might go up to something like fiberglass bags, which are more delicate. So we have to take some extra precautions if we use fiberglass bags. For example, we have to use special cages that have extra wires on them for fiberglass. But these could be used on some dryers and kiln applications. We'll have to take some extra precautions. Now, in certain spots, you might have a mix of chemicals, moisture, humidity, different things going on where you can have acid reactions. Now, in these cases, we might use a different medium that's especially resistant to those kinds of chemicals, things like acrylic bags, or maybe bags made out of PTFE felt. Now, a very common, I'd say the three most common additives or treatments we put on top of the filter media. We take, if it's polyester, aramid, or fiberglass, whatever the base media is. Very commonly, we will apply on top something that is a acid-resistant finish. We'll also apply a hydrophobic, oleophobic coating that repels oils and waters. And then in many cases, where we need to collect a higher percentage of the absolute smallest particles, or if the material we're collecting, for example, is extremely toxic, highly regulated, whatever it might be, then we might apply on top what's called a PTFE membrane. This is different from PTFE filters, where the bag is made out of the PTFE. And it's not just a spray coating, which unfortunately we've seen some manufacturers start promoting the same way. PTFE membrane is a separate filter material that's made and then laminated to the surface of the filter bags. And it has the effect of capturing more of the smaller particles and allowing for the dust to release more easily. So these are just a few of the common filter medias you'll see in the baghouses. And if you see in the slide here, what you're seeing is a mix of bags that are folded, the wire cages that support them, and then next to those, you see pleated filter elements. These are a special kind of filter that we can put in our baghouse. We'll come back to that in a sec. First, let's go to the next kind of dust collector that we often see, which is cartridge collector. So cartridge collectors, this terminology is important. Cartridge collectors use cartridges instead of bags. Excuse me. Use cartridges instead of bags. So instead of a bag that's 6 inches by, say, 10 feet long, the cartridges are usually 12 to 18 inches in diameter and maybe 20 to 40 inches long. This picture here you'll see is a standard horizontal design where the filters go in horizontally. Others use vertically oriented filters. But in both styles, they basically mimic the baghouse where you have dirty air comes in, captured on the surface of the cartridge, and then clean air exits through the back of the cartridge collector. Just like a baghouse, it's just rotated the orientation a little bit. The cartridges work very, very well at collecting at a high efficiency, so getting very fine medias. And they're generally cheaper than baghouses because we're packing a lot more filter area onto the cartridge than a typical bag. One cartridge, for example, has the equivalent amount of filter area because the filter is pleated and jammed on there. One cartridge has the equivalent of sometimes like 10 to 20 filter bags. Now, the downside of this is that because it's all jammed on there tightly, it's a little bit more difficult to clean the filters, and they can't quite handle the same dust loading or the amount of dust coming in as the baghouses. So we often use the analogy the baghouse is like a big heavy pickup truck that you can do everything with. You can go off-road, you can carry people, tow things, drive on the highway. Cartridge collector is more like a van. So if you're just carrying a lot of volume, light materials, big empty boxes, the cartridge collector, like a van, is a more practical system to have. In mining and cement, we don't see them used so much because most applications for mining and cement have a lot of dust that comes in. Cartridge collectors are especially good when we have a lot of air to clean that has a little bit of dust in it. In those applications, they absolutely make sense, and they can be a lot cheaper than a baghouse style. Now, there are some differing opinions. A few manufacturers recommend them for cement and mining applications. Most in the industry, however, decide not to use them. If you are going to use them in a mining or cement application, we do recommend you use the other style where the cartridges hang vertically, as opposed to this style you see here where they're horizontal, because this can have problems where the dust builds up on top of the filter and it can't be cleaned off when there's a lot of dust coming in. Now, if we go back to thinking about the Baghouse filters, we expressed about the pleated filter elements here. So a common way to get the benefits of a cartridge collector in cement and mining is to take a baghouse and then use these pleated filter elements. So these pleated filter elements are a type of cartridge that is designed to retrofit into a baghouse. So they have some of that where the media is pleated and jammed onto the filter, so it has more filter area than a bag, but it's not jammed so tightly like the cartridge collector cartridges, where you get a lot of the problems where the dust can't be removed and things like that. So usually we see these retrofitted into existing baghouses, but sometimes we do new systems with them as well for mining and cement. More often they're used when we have bin vents or small systems as opposed to a very large baghouse. But absolutely something that you should investigate in some of your applications with someone like us to see if it's a viable option, because there's a lot of benefits to switching to the pleated filters in your baghouse. Now, moving to the last kind of collector we'll discuss, which is when we have just a silo to vent or enclosed space, we often use what are called bin vent dust collectors. So here you see a picture of one. Bin vent dust collectors are basically just baghouses that have the bottom section cut off, have the hopper section removed. So that's why they look like 2/3 of the baghouse. Everything else is exactly the same. They have the same filters, the same cleaning mechanism, the same controllers. Where they are used differently many times, though, is whereas a baghouse usually is pulling air from something with its own fan, bin vents are usually placed on top of something where you're pushing air or pushing material into. So the most common place is on top of a silo, or sometimes weigh bins or very large day bins. And the reason we put them there is because as you blow air in with dust, it displaces the air that's already in the silo, and it needs to be vented out. So if we didn't have some kind of bin vent dust collector, two things would happen. Either the vessel would start to pressurize until it pops open, or you would pressurize it and then the air and dust would go backwards through the loading line. So we have to have some way to vent the air out while leaving the material inside. So most common setup, big silo, where when the trucks or trains come and they blow the material in, or you have a big screw conveyor that drops material into a silo, on the top of the silo, you have a bin vent dust collector. As the air is displaced, it goes through the filters and out the dust collector just like normal. Sometimes they have a fan that helps pull the air through. Sometimes they don't have any fan. So only the air being pushed in is what goes out through the bin vent. Other times it's both things. The air is being pushed in as well as the bin vent has a fan pulling out. But in either setup, it essentially work the same way as your normal baghouses. A lot of times these are the most neglected and overlooked dust collectors in the plants because they're often very hard to get to. They might be used intermittently. And because of that, it's hard to monitor them. It's hard to check and keep them in good condition. So a lot of problems with silos, with loading, unloading, these kinds of things. A lot of these come from not having the bin vent either sized correctly or maintained well. So they're definitely an area when we go and do inspections and system audits, it's definitely an area where we see a lot of plants lacking and where they can make improvements. Now, just the last area we'll talk about is material conveying. So material conveying is used in many different parts of plants, cement and mining. Most commonly for these applications, you'll have some kind of screw conveyor that moves the material around, so mechanical means. You might also have a belt conveyor or maybe drag conveyors, other things like that. But a lot of applications within the plant, you're going to be using pneumatic conveying. Now, when you have pneumatic conveying, you're taking material and you're blowing it or pulling it through basically a small piece of ductwork. We usually call it piping to another space. So in these systems, like we said with filling the silos, for example, you might blow material from your truck that comes with material to deliver, blowing it up into the silo. That's pneumatic conveying. Or you might, from the silo, have it go down and load the truck or a barge or a train car. In that case, you're also doing material conveying, pneumatic conveying. So dust collectors in these kinds of applications, you see them, sometimes they're in the form of bin vent silos, like we said. Other times you'll have round dust collectors that are called filter receivers, where you blow to them, or maybe they're a vacuum system pulling. These are essentially just baghouses that are round so they can handle higher pressures. But these systems, for all intents and purposes, function the same way as normal baghouses. Sometimes as well, when you have lots of screw conveyors, these, depending on how they're used, usually need some kind of dust collector hooked up to them to pull the air through because they make a lot of dust. So your screw conveyors, your bucket elevators, your discharge points between the belts, if you have a lot of belt conveyors dropping one to another, all of these spots, you usually need some sort of dust collection at that source in order to avoid having fugitive dust emissions coming up. So looking at your material conveying is often where a lot of the dust collection needs in your plants are going to be. Now, if we go to just a few points here about system design considerations, some of the most common things that we get asked that come up with regards to mining and cement applications are these. Source capture. In general, the closer to the source of the dust that you can put the pickup of the dust collection, the better it's going to be. If you try to vent a large area, it quickly becomes impractical. The same dust collector that has 1,000 filter bags that can handle your dryer, if you try to vent a single room, can only handle perhaps a room that's 20 by 20 and only pick up light dust. Whereas if it's with hoods and ducting going right to the source, that same dust collector can handle dozens of pickup points throughout your plant. So we almost exclusively need to do dust collection at each source where it's generated. A few things with ductwork design. Ductwork in general is the thing that takes the most amount of engineering and time when we're designing a system. People think it's the baghouse or the dust collector, but often I'd say 80% of our time and efforts go into designing the ductwork. And a lot of the problems that happen in older cement and mining plants are because the ductwork over the years gets changed, modified, neglected. And each time it's changed a little bit or repairs are done in a less than ideal way, it's the death by 1,000 cuts. And that's how you end up with a lot of the problems at these facilities are because the ductwork is not ideal, not so much the baghouse. So designing it correctly in the first place, but also understanding the importance that ductwork is not simply connecting hoses to things. There's a lot of engineering that goes into it. And you may need to review the system you have in its current state in order to see where it's deficient and then make changes. But basic principle we want to get across is that ductwork changes are something to be done only in consultation with a dust collector or mechanical engineer, dust collector expert or mechanical engineer, because there's a lot going on there. We talked a little bit about filter media selection. In general, we want to make sure we're selecting the best filter media based on the temperature, but then also if there's things like moisture to take into account, other chemicals in the gas, also the particle size and the dust loading that the system sees. All of these play into what kind of media we select. Another thing that comes up often is centralized versus point of source collection. So centralized is where you have a single dust collector that's connected via ductwork to many different dust sources. This is the standard type of system. Point of source collection is where you have the dust collector built into the thing making the dust. Now in older plants, this was done a little bit more often, I would say, than in more modern plants. So you might see older dust collectors built into, say, a really big screw conveyor or on certain belt conveyors. This approach has mostly fallen out of favor because the kinds of collectors that you can make so small and stick on the belts and all that really are not ideal. They don't function well. So a lot of design practice has kind of abandoned that approach. There are still very few moments where you'd want to do that, but in general, the larger centralized system is going to be the way to go. And that doesn't mean that you have one massive dust collector that collects from all over the plant. It's generally better to have one collector for a certain group of sources. You know, maybe one to handle all the conveyors in one part of the plant or one room for example, or on the dryer, things like that. But those are still centralized systems in that they use the ductwork to pull the dust back to the dust collector. Um, and then another common thing that needs to be looked at is hopper design. Make sure that we have a sufficient design that allow the dust to be removed and not get stuck in there. So that may involve using things like vibrators or aeration devices that keep the material flowing and emptying out of the baghouse. But also, whatever comes under the dust collector, so the rotary airlock, and then whatever's underneath after the discharge, we need to consider that as part of the entire system. Many times people think of those as different things, but a lot of the problems in cement and mining applications with dust collectors can be traced back to the discharge underneath. It goes into a screw that goes over here. That backing up or not being sufficient to remove dust quickly is a cause of a lot of the problems we see. So you have to think of all of it together. The ductwork, the hoods, the ductwork, dust collector, the discharge underneath where it goes, as well as the system fan, obviously, all of that together as one dust collection system. And by doing that, you can avoid some of those problems. And then finally, one last thing that we often see when we do inspections is the cleaning system setup. Most, if not all, modern dust collectors in these applications are going to be pulse jet style, where they pulse the filters with compressed air. Many times we find plants where they have it set on cleaning just on timer mode. So just clean the filters every 30, 60 seconds, all day, every day. And this results in a lot of over cleaning, wasted compressed air. The over cleaning wears out the filters much faster than they otherwise would. It's a huge waste of resources of compressed air. Plants sometimes get nervous thinking that if they do something else, it won't be sufficient and the system will back up. A much better option is to have it be a clean on demand system where the system automatically cleans when the differential pressure is high and then shuts off when it's not. Because they're often neglected or not set correctly, plants think that those systems are unreliable. So they prefer to just keep it on the timer setting. But they're really doing themselves a massive disservice by doing that. Better to fix the problems of neglecting them as opposed to just ignoring those kinds of systems. We find in many cases where plants are wasting tens of thousands of dollars in compressed air, as well as dramatically shortening the life of their filters because they just have it on a timer setting. So it certainly is worth the effort to put the clean on demand there and then to maintain it well so that you can see the benefits. Okay, lastly, just a few things we want to mention with maintenance, monitoring, and optimization. So every single dust collector in your plant should be equipped with a differential pressure gauge, and it has to be working. It's one of the most tedious and most routine things that we can do, but it's the first thing we mention whenever we do a visit is making sure the differential pressure readings are accurate and reliable. We don't have that reading, and we can't rely on it and trust it. It affects everything we do with regards to maintenance, operation, planning. So we absolutely have to make sure that that system is functioning correctly. This might mean cleaning out the gauges, cleaning out the lines, either weekly or bi-weekly, or installing a device that automatically purges the lines and keeps them clear and clean. But if we don't have that information, we can't make any intelligent decisions about maintenance and operation. So we have to monitor it many times as well. Simply upgrading the gauge from a basic magnehelic gauge, which is just a mechanical gauge you look at, to one that has a 4 to 20 output will allow all of those readings, especially those far-flung bin vents on the top of the silos that takes 20 minutes to get to and up a 150-foot ladder, sending that differential pressure reading down to the control room via 4 to 20 gauge for the extra $50, $80 it costs, was an incredibly wise investment. So making sure those are monitored at all times. And it's also easy to access, reduces a lot of unnecessary labor. Then you're going to obviously want to monitor for any leaks or emissions, whether it's coming out of the dust collector, coming out of the exhaust stack, but also in the plant where you might see fugitive dust coming out of some of the sources. If it's not collecting enough of the dust and the dust is getting out, it means there's a problem somewhere. Other things you can monitor if you really want to try to optimize, especially on your larger, maybe your key systems, how much compressed air you're using, the pulse valve performance. You might also want to have something that's monitoring that dust is being discharged through the airlock on the bottom. things like fan vibration, RPMs. You can also monitor emissions coming up to track the life of the filter bags. All of these things can be done on any unit, but we recommend them particularly on your most important units, your crushers, your dryers, anything that's permitted, because that's where you're really going to see the most benefit from it. And then finally, a lot of things that cause poor performance in the dust collectors can be traced back to shortcoming in the maintenance plan. So using the wrong kind of filters, letting them run too long, um, not taking care of these basic regular maintenance tasks. But some of it comes back to design flaws. So things like using the wrong filter media, undersizing the dust collection system, not designing the hoods or the source capture very well, or as we said, modifying it over time, adding more pickups, diverting things around, butchering and chopping up and pasting back together the ductwork. Um, Also, though, things like not having the dust collector settings correct. All of these kinds of things affect greatly performance elsewhere in the plant. So if you have a dust collector where you see a lot of dust forming at the pickups, or it's just dusty in your plant, you have to look at the whole system and find out where the problem is. Not often just that the baghouse is not doing well, it's often a victim of other things. So being able to diagnose and troubleshoot problems from a systemic perspective is really essential to making sure that you get the best performance out of your systems.